So welcome to this breakout session number 6 about circular economy. My name is Laurent from the French National Institute of Research for Safety at Work, and Anses asked me to chair this session. Let me first present what will be discussed today. This is about circular economy. Circular economy is often considered to be the solution to address the scarcity of planetary resources in the future. It requires, for instance, repair, reuse equipment to increase the lifetime, to dismantle equipment and reuse components as much as possible, and eventually to recycle the materials, for instance, the metals, rather than extracting new materials. And all this has to be done in principles with low carbon emission. This implies closing loop at various scales in space, from local space to global space, in time, up to several tens of years, even centuries for some buildings. And I would like to stress the point that this time and space scales are often larger than the scales at which regulations apply. So, more precisely, what will be discussed today is a question relative to circular economy, because it requires evolution of regulation, sometimes dilemmas. For instance, there may be a contradiction between sustainability and consumers' health. For instance, when you recycle materials, you also recycle unwanted molecules, sometimes banned molecules. You have also a contradiction between sustainability and occupational safety, because this requires to work on unknown equipment 20 years after first use, when no more information is available, and also possible to work on materials with banned molecules. There are already examples, of course, such as asbestos or flame retardants. And also, at the origin of some dilemmas, there are many scientific and technological unknowns. So I have the pleasure to introduce the 4 speakers. They will discuss some of the point as discussed just before. So Walter Stahel, director, founder of Product Life Institute. This is the oldest consultancy in Europe working in this domain. He will explain us what is circular economy and its integration with other concepts. Charles Bodar from the Dutch National Institute for Public Health of the Environment. We will discuss the couple circular economy and hazardous chemicals. Michel Héry from the French National Institute of Research and Safety at Work will discuss implications for occupational safety. And Clark Miller will discuss sociotechnical intricacy of circular economy. So each speaker will have 20 minutes to give his presentation, and I suggest that the question will be at the end, because many points are common to the various presentations with different angles. If you want to ask questions, you have a chat. You can ask questions on the chat, and we shall try to make the synthesis of your question at the end to discuss this with the speakers. Last point. A replay of this session will be available later. Everything is recorded and will be, I hope, available, I think, in 1 month. So let's start. So Walter, the floor is yours.
Thank you, Mr. Chairman. So I'm going to give you an overview over a very complex thing, which is the circular economy, or rather circularity. I have problem getting the cursor. Well, anyway, let's start. Nature, so the bottom left, top left, is circular by evolution. It is inherently sustainable and there is no waste in nature, as objects at the end of their life become food for others. Nature does not know ownership, liability, or cultural and moral values. Within nature, go to the top, I don't have the cursor, so go to the top. Water and people are overarching renewable resources which are unique and cannot be replaced by manufactured objects. Without water, there is no life. Without people, there is no society or economy. And also, people are the only resource with a qualitative edge. Its quality can be greatly improved through education and training, but skills and mental health may rapidly deteriorate if unused. Since the beginning, humankind lived roughly within the limits of nature's regeneration and absorption capacity, often in a circular society of scarcity or poverty, which is the green loop that I cannot show you for one reason or another. But it's the green loop between nature circularity and the Industrial Revolution. Then 1945, halfway down, when I was born, 10 months after the start of the Anthropocene on August 6, 1945, natural resources and nature circularity were dominant. There was no plastic in the oceans, not a single man-made object in space, no man-made materials like synthetic hormones or toxins in circulation. The second speaker will talk about these man-made toxins. Within 2 generations, since 1945, scientific humankind has radically changed this situation through innovation in physics, chemistry and metallurgy, which combined with mass production technology have created the issue of embodied water and CO2 in the immaterial world. So now you have to move to the right. You see the Anthropocene, the circular industrial economy, and the embodied water and CO2. I apologize for the pointing, but you can see certainly the oval with embodied water and CO2. So in the industrial economy now we have to deal with immaterial topics. Quantitatively speaking, the Anthropocene has polluted air and water from industrial activities and produced volumes of end-of-life objects made from synthetic man-made materials based on natural resources. The green arrow, now it works. The green arrow but these wasted resources mostly end up in nature and are outside nature's circularity. Nature cannot deal with it. Humankind in the industrial economy has to become circular, closing material and liability loops and accepting full liability for its creations. Nature cannot deal with our synthetic materials. Then next came the Bioanthropocene, merging the biocycles and the manufactured world, and the digital economy, merging the material and the immaterial worlds. Industrial humankind is now faced with 4 gigantic tasks: creating a way of life within the regeneration and absorption capacity of nature, going back basically to this situation, and respecting the integrity of the global commons, oceans and space. Cleaning up the legacy waste of the Anthropocene, plastic in the oceans, microplastic in the soil, satellites in space, CO2 in the atmosphere. And the third one is preventing future legacy waste by developing waste-free and toxin-free solutions by merging the material and immaterial worlds and by innovation into circular sciences in chemistry, metallurgy, and energy. The keys to the latter are corporate strategies, internalizing the liability for risk and waste, such as performance economy, selling performance and objects as a service. National policies of adapted framework conditions, including taxation, public procurement, license to mine combined with the leasing of atoms and molecules. And these together form a mature circular economy. Quantitatively speaking, humanity has become a dominant force in shaping the face of Earth. The overall material output of human activities, referred to as anthropogenic mass, now equals the overall living biomass on Earth. A recent study by E. L. Hachem, published in Nature, has found that Earth is at the crossover point. In the year 2020, the anthropogenic mass, which has recently doubled roughly every 20 years, will surpass all global living biomass. In other words, humankind today has reached a major turning point where we become responsible to protect nature and deal with our own legacy. Society needs a new creativity to shift wealth creation and welfare through production flows which increase anthropogenic mass, shift it to caring for existing stocks of natural human manufactured or anthropogenic capitals with the objective of maintaining their existing value, utility and quality for the longest period of time. The objective of this is to stop anthropogenic climate change, create local jobs, protect the environment, and safeguard the global commons. A circular industrial economy marrying the 3 worlds of nature, circularity, manufactured world, and immaterial world is one strategy to achieve this goal by applying innovative, sustainable solutions. Thank you for your attention. Thank you, Mr. Chairman.
Thank you very much.
Back to floor.
So let's move to Charles, next speaker. Please, Charles.
Yes. I can start? I can start. Okay. Okay, good afternoon. I will tell you all some more about chemicals, especially hazardous chemicals, chemicals of concern in a circular economy. And my subtitle is whether these two things are a happy couple. This picture is familiar to most of you. We come from what is called linear economy, and in between we are now more or less facing a reuse economy, and in the end what we're aiming at is a circular economy. And the point is that what I said, I have to learn the pointer, that if hazardous chemicals are either in products or in waste, those hazardous chemicals may go with these flows. And the question is that a situation that is wanted? To show you a little bit more some examples whether hazardous chemicals and circular economy, whether they are a happy couple, I demonstrate here some pictures of materials which demonstrate what I called the examples of friction. I won't go through all of them, but you can see some, the pointer is difficult for me, hazardous compounds like lead and cadmium can be present in PVC, which is reused, and in that case it may be continuing in second and third and further life cycle stages. Another one is HBCDD, a flame retardant, which is used in building material. Another one is a phthalate in soft PVC. Another brominated flame retardant in hard plastics. And if you want to recycle the hard plastic, the flame retardant will keep on going in that flow of new products made from that recycled hard plastic. An example which I will go further in is the rubber infill. I think it's a familiar case in many countries for you. Rubber granulate, which is made of used car tires. They are recycled, and rubber granulate is made of it, and it's used as infill. And these granulates are known to have a number of hazardous compounds in it, for example, PHs. And the last one is POPs, persistent organic pollutants in electronics, which may also be in the flow if those electronics are being reused.
Speak a little bit slowly for the interpreter, please.
Okay. Pardon? This slide shows you some things about current understanding. The Netherlands, for example, is ambitious. We want to make CE transition, and the aim is to be 100% circular in 2050. So that's a very ambitious statement. More or less the same holds for the EU. The European Commission last year released its chemical strategy for sustainability, and they clearly express that they want to minimize the number of substances of very high concern, and this all towards a non-toxic environment and also to non-toxic material cycles. But that may be ambitious, but the challenge is not easy. For example, at present at the EU, a number of 200 million tons of hazardous chemicals are used in products. And that is a figure of 2013, and I'm sure that the figure nowadays is even higher. And it doesn't say anything even about imported articles from outside the EU, which may also contain numerous hazardous chemicals. So a short-term challenge is how to deal with it, how to phase out or manage legacy substances of very high concern in waste stages. Should we burn them or should we recycle them? That's an important topic yet. And the opinion in the Netherlands nowadays is try to recycle them as much as possible without any harm. I will come back to that later. A little bit more. In fact, what is from a chemical risk assessment perspective is very important, that facing and managing potential risk of chemicals in a circular economy deals with the fact that you have to anticipate new routes of chemical exposure. Because once the chemical is brought back into the cycle and used in second and further life cycle stages, new routes of a chemical exposure may be foreseen, because the chemical is used in products which they were not originally intended for. I want to express that it's not only chemicals, substances of very high concern, so industrial chemicals, but it's also dealing with pesticides, pharmaceuticals, and pathogens that may face the same point, anticipating new routes of exposure. And a very important topic is also, which is really hampering many good aspects in a circular economy, in a safe circular economy, is that there is a big gap, a big lack of monitoring data of the contents of those chemicals in either products or wastes. And finally, on this slide, it also deals with public perception. You can make a perfect risk assessment for a product for all the life cycle stages with new products, etc. But if the public perception is against you, you may demonstrate a hardcore risk assessment, but you won't make it because the perception is against it. I showed maybe a little bit ridiculous example below. You've got toilet paper which goes into the sewage treatment plant, and if you sieve out the used toilet paper and you take a number of used diapers, you can make a box of it, for example a pizza box, which is a food packaging material, and you can imagine that although you demonstrate that it's safe, public perception will be that, well, please bring the pizza to my neighbor, but not to me. So public perception is also very important in reaching a safe, solid circular economy from a chemical point of view. A case which I mentioned already before, learning by doing, is the rubber granulate case. And what I wrote down in red, it looked so promising 10, 15 years ago, because we all found a new life stage for used car tires, which we all thought was better than burning. The sustainability goal was also perfect because there was a reduction of the use of virgin raw materials. It was also cheap. It was a cheap infill material for artificial pitches, and it also had a good technical performance. So sunny side, no clouds in the sky, it all looked perfect. But this picture shows you some newspapers from the Netherlands from 2 years ago. It's in Dutch, but it all expresses that those rubber granulate is causing environmental problems. Once they enter the environment, the chemicals which can be hazardous, such as zinc, PAHs, cadmium, it may leach out, it may enter the local environment, and it may affect the local environment. So there came a lot of red traffic lights related to this recycled material. But, as I said, it's learning by doing. RIVM, which is below here, which developed a method which we call the Safe Sustainable Material Loops methodology. And it was interesting to look a little bit more closer on how rubber granulate would go through this methodology. And here you see a number of boxes varying from circularity to toxicity. These are less relevant here, but also environmental impact that deals with the carbon footprint, and the other ones are not relevant here, so in this case. And it showed that it's done with colors, but it's also a quantitative method, that from the perspective of toxicity, substance of concern, it's a red light. From the point of circularity, it's orange because the loop is not closed. That means that a lot of that infill material is released into the environment, so you have to refill it several times, which is not a good score for circularity. And on environmental impact, the score was green. That means more positive. And this picture shows you this sustainability score, the carbon footprint. If you compare rubber granulate, so made from used car tires, if you compare with alternatives, for example, virgin plastic or recycled plastic, compared to this one. This is the granulate made from used car tires. And you show that the carbon footprint of the recycled car tires is much lower than, for example, virgin plastics. So from that perspective, it's balancing. The green score for this material is clear. So we developed a methodology to weigh those things. You can compare apples to pears, we say in Dutch. And it's a methodology to be used to make steps towards a safe circular economy, and taking also the other aspects into account rather than just the substance of very high concern. Try to balance it as much as possible. So here's some challenges, even more. One is how to deal with legacy substance of very high concern. For example, lead in PVC. It's a fact, it's in there. That's a huge amount of material present now in our society. And if we want to recycle it or reuse it, we have to deal with the fact that these chemicals are in that material. The second one here is new substance of concern will be identified. These are European REACH figures. REACH is the European Chemicals Legislations, which shows that at least 1,400 chemicals will fulfill the criteria for substance of concern. So you're always lagging behind, I would say, that you try to make a safe loop, but then suddenly it turns out to be that chemicals is more nasty than we thought before. And another group of chemicals, about 300, is now already identified as potential SVSC. So they will probably become also categorized as a substance of very high concern. So you also have to deal with that fact. Another important one is how to deal with essential uses. This is an example, terphenyl hydrogenated, which is used in a heat transfer fluid. It's really the one and only chemical that may be used for that very important purpose because of its functional characteristics. And you may ban all substances of high concern in our society, but how to deal then with the fact that you miss those important chemicals in certain what is called essential uses. You have to deal with that. And the final one here is that, yeah, you've got new developments in society. For example, the enormous increase in lithium-ion batteries for, let's say, green power purposes is at present containing several of those hazardous chemicals. And it looks so promising that you help society with green energy, electricity, but the dark side is you have to, at present, still use nasty chemicals for that purpose. Oh, and now when coming more to solutions, we think there is no easy one-size-fits-all solution, but that doesn't mean we cannot do anything. On the contrary, I come to that now. This is a picture, a decision schedule developed by RIVM, showing what I call short-term solution, how to deal with legacy chemicals of concern that are present in present materials. Rather than just simply burn all the materials, The positive side is you get rid of the nasty chemicals as well, but on the other hand, you have to use a huge amount of new virgin raw materials, and that's what we don't want in circular economy. So as a kind of in-between solution, we think it could be possible if the waste stream is not having that much of a content of a ZZS, which is similar to substance of very high concern. If the waste stream is containing a minimum amount of dangerous chemicals, then we say there is a possibility to use it. If it contains more than this limit, then we think you have to closely look at it more in-depthly, and then you have to decide if you want to do a risk assessment or whether you simply disregard that waste stream and burn it. So we try to be as pragmatically as possible, as long as many of those legacy chemicals are available. But what I already said in the beginning, the problem is for many products nowadays, and the same is true for waste streams, we miss data on the actual contents of those nasty chemicals in those products. And that's seriously hampering this possibility. And so there are ideas of making a kind of track and trace system for chemicals in our society. And many people also are in favor of making a kind of material passport so that you know where each chemical is going to and whether it's safe or not used in further life cycle stages. I think that's a possibility to find out, to discover further as a short-term solution as long as we have those chemicals in our society. Now I go more towards what I call more systemic solutions, and there are many of them, and two I want to highlight here at the end of my presentation. This is, I think, a very interesting one, and that's a discussion which is currently very actual, very active in Europe as well. I mentioned earlier the European Chemical Strategy on Sustainability, and they also pinpoint that we as a society really have to look at what uses are we consider essential for our society and what uses are we considering non-essential. And here is an example for Pfas. You may have the perfluor group, which is, I'm sure, very relevant for many of the countries you're in. It's a picture from a Swedish colleague, Cousins, and it demonstrates his schedule in categorizing chemicals in uses in non-essential, substitutable, and essential. And for example, for Pfas, an example of a non-essential use is the use of Pfas in ski wax. And the idea behind this, let's consider this type of uses, and if we can find a mechanism, because it's not that easy to bring this forward actually in a free open market, if we consider those uses as non-essential, then we have a reason to restrict or to ban these uses, including the use of chemicals in those uses. That may be a way forward, which is attractive. There is an in-between group, the second one. An example here is in water-resistant textiles, coats, where those chemicals are also used. And it's not directly considered as non-essential, but it's considered as category 2, substitutable. And for that, this concept is stating that those chemicals, there is a real trigger for substituting those chemicals by safer ones with similar functional properties, but with a much lower hazard profile. And the final one is the essential uses. For Pfas, there are examples in medical devices for which alternatives rather than Pfas are very difficult to find at present, and also in occupational protective clothing For fire workers, there you may consider the use of PFAS still essential, and that would be at present difficult to substitute those chemicals immediately. But there should also be a trigger to go for substituting those category 3 uses. Now, that may be a way forward of dealing with unwanted chemicals that we try to unravel to make a kind of framework that we distinguish between essential and non-essential uses, and then really try to also bring that to the use of hazardous chemicals in these products. My final slide is also showing one of the systemic solutions, and we call it the Safe by Design. It's focusing reducing potential health and environmental risk of chemicals, materials, products, and processing by addressing safety aspects, and that's very important, at an early phase of the innovation process. We think that that's really something to pinpoint, to emphasize that rather than what's happening now, that rather late in the process or once a regulation is showing a red light, then the thinking starts, that we really emphasize that this should be done much earlier in the process. And that can contain several aspects. Other business model, but for example also non-chemical solutions. And an example, for example, is the use of bisphenol A, which is known to be an endocrine disruptor, which is at present being used in cash receipts. So if you go to the supermarket and you pay, you get your bill out of the machine, and it's known to contain bisphenol A. It is said to be very difficult to replace that, otherwise the function is hampered of that cash receipts. And why not consider the use of those paper receipts as unnecessary, and try to find a non-chemical solution that you simply have your receipt on your smartphone. So then you avoid using paper, but you also avoid using nasty chemical from being used, because there is a non-chemical solution. Now, other processes may be developed, other materials, other chemical groups, but also very important when applying the Safe by Design concept, it also has to look at sustainability and circularity rather than just focusing on safety aspects. So there's more than just the hazard profile, it's also dealing with, for example, the carbon footprint. And finally, whereas now it's mostly regulations like REACH who play the policeman showing a red traffic light for a chemical that it should be banned or restricted. We think that it should not only be regulations in Europe or wherever on the world, but especially what I call market opportunities, also consumer market pools, what consumer wants. We consider that it should much more, the Safe by Design concept should be more something of the society as a whole than just of the chemical industry forced by regulations to move towards safer solutions. It should be, yeah, what I said, much more be a basic, fundamental new approach for using chemicals in our society towards a safe circular economy. And then I think chemicals can be a happy couple in together with circular economy. And that's my last slide in the best French I could find. And thank you for your attention.
Thank you very much, Charles. Okay, next speaker is Michel Héry. Please, Michel, we are in time, so speak slowly, please.
Here I am Hello, I'm Michel Héry. I work at INRS. INRS is the French institute in charge of the prevention of accidents at work and occupational diseases in France. This is the French equivalent of the American NIOSH, which you might know a little bit better. My aim today is to present to you the result of a foresight exercise that we have dedicated to the circular economy, especially to the possible consequences on health and safety at work for workers. Concerning the definition of the circular economy, we have adopted the definition of ADEME. ADEME is the French environmental agency. You can see this definition on the right, on the figure on the right of the slide. It's a fairly broad definition, since it includes topics such as the design of goods, of course, the sustainability of resources, of course, but also consumption patterns, sharing economy, for example. I don't think I have to dwell on this since that was perfectly explained very well before. Next slide. Yes. Some other preliminary points. Of course, we have full confidence in our environmentalist colleagues, but we believe there's a need to conduct a specific reflection on occupational health. Some words about foresight. Foresight is it's a decision-making tool, but for us, it's for me at least, it's above all a tool that makes people think about today's situation to better project themselves into the future. It's for this reason that I've included in this slide the title of a recent communication, which is some kind of a mantra for us. It says strategic foresight in occupational exposure, preparing the future, but keeping both feet in the present. For this talk, I have arbitrarily chosen to focus on a few changes related to circular economy, which can have much influence on the working conditions. And I use them to illustrate my reflection, the reflection of the group. First item, the existing productive apparatus will change, and it will change deeply. Second item, part of the relocated production today will be reshored in our developed countries. It will be reshored tomorrow. Third item, the way goods are designed will change because consumption modes will change. Fourth item, new activities will emerge or become more important than they are all today. I speak about a repair, I speak about deconstruction of goods, I speak about recycling, etc., etc. And fifth item, the supply chain is going to be deeply modified in the years to come if circular economy is getting developed. Let's talk a little bit more about the first item. Maybe the transition will be slow, but we know that the change will be profound. As I told it before, production will be reshored, and existing installation, existing plants, existing factories will be modified. It seems obvious to us that this will be accompanied by a strong automation of production. First, it's in the spirit of the times. Robots are much better than men. And second, more important, it's indispensable since certain dangerous processes will reappear. We had we had relocated these dangerous processes, and maybe they will come back in our developed countries. So we think that it's therefore necessary that all measures to prevent professional risk be taken at the time of the change. It will be later if they are taken after. It won't be prevention. So when you change the process, you have to take care of the working conditions. Just a little word about robots. In my laboratory, we are very, very interested in the interactions between men and robots. And we see today that in some cases, in some firms, the relationship, the importance of the relationship between a robot and a worker is underestimated. And when it's taken into account, it's often too late. I would like to tell again a principle which is very important, another mantra for us. It's that the robot must be at the service of man and not the other way around. The work pace must be sustainable for the worker. I don't care about the robot. And the man is in the center of the production apparatus. Second item, a major change in design. The transition to the circular economy is marked by a change in models, in goods, in the models of goods, but also by a change in the way of conceiving these goods. The goods now in a circular economy must be stronger to last longer. They must be usable in shared use. They must be repairable. They must be deconstructible so that certain elements that are not worn out can be reused, and the materials can be recycled at the end of life cycle of the goods. Honestly, this is a complete change for designers who have to integrate all these new environmental elements. And I'm here to speak about safety at work. And I say that the designers must also ensure that all interventions on these new goods can be carried out in complete safety. I mean, once again, repair, deconstruction, recycling, etc. There will be definitely big needs in training for workers. There will be also big need in growing the awareness of workers. A rather important part of my talk, occupational health and safety impacts in circular logistics. One of the objectives of circular economy is to save energy. So we could think that circular economy should decrease the movement of goods. It's the contrary. There will be more movement of goods, but over shorter distances. We'll see that on the next slide. Automation, I speak again about automation, is partly possible for logistics, but there are still tasks that will have to be performed by humans. at least in the beginnings. Maybe in 10, 20, 30 years, it will be different. But at the moment, when you transform, when you go from a linear economy to circular economy, you still need people, you still need workers, because it's a question of dexterity, it's a question of intelligence. The collection of used goods, their deconstruction, their grouping by categories, it's a matter of skill and intelligence. Some robots can do it. They can't do it. Sorry, in a good way at the moment. It confirms the importance of the design. Goods must be designed in a way to allow workers to deconstruct them easily, and preventive measures must be taken at all stages up to final recycling. We come back in this slide now on logistics itself. This diagram illustrates the multiplication of trades and the secondary flow. Secondary flow, these are the blue arrows, that the circular economy creates. These secondary flow do not exist in a linear economy, or they are less numerous. The purple point on this figure are the retrieval and disassembly centers. We have some, but we will have much more tomorrow. And in a linear economy, the only existent arrows are the, I don't know if it's yellow or it's green, but they are the arrows at the top of the figure. As there are many secondary logistic flows, there are many occasions to touch, to carry, to discharge goods, and it's a risk of accident. When we know the current difficulty to organize these exchanges in a rational way, today many containers or wagons travel empty. We understand better the challenge of rationalizing secondary logistic flows. It's these flows are occasions for accident, and they will have to be performed perfectly. There will be the development of technology is one way of solving this problem. The objective is to develop a physical internet that will make it possible to group and route goods to be transported by optimizing flows. That's an approach that is of great interest to specialists in occupational health and safety. The standardization of tools in logistics can facilitate handling. It can rationalize transport. Anyway, the big problem remains the logistic of the first and last kilometer. It's more difficult to automate, and it results in many accidents of illnesses, falls, low back pains, musculoskeletal disorders, etc. The need for item 4, the need for an efficient system for the traceability of goods. The reuse of certain elements can pose problems. Charles Bodar explains the situation for materials and waste. When deconstructing a good and wishing to reuse one of its components, one must ensure that this component is in good enough condition to withstand further use. This is even more important in terms of professional risks. This element may be subject to greater physical constraints when it's dismantled or reassembled than the constraint encountered during its use. This can be very dangerous. It will be necessary to find an efficient tracing system to be able to track the parts over time, use by date, maximum number of uses. All this can be very costly in terms of energy. You know, the blockchain is very costful in terms of energy. Fifth item, the importance of job statuses. You might be surprised that the slide is devoted to the question of the workers' employment status. In recent years, our laboratory has taken a great deal of interest in the relationship between employment status and the ability to organize occupational risk prevention. The latter, occupational risk prevention, is very much reduced in the new status of self-employed workers, gig economy, you know that we've seen emerging in recent years. The circular economy can, for sure, develop highly qualified jobs, but it will also develop other jobs which are not high qualified, repair activities, the construction of goods, or in waste treatments. For these latter jobs, prevention of occupational risk will remain important, and it won't be possible for a freelancer to organize it. I would like to finish this talk. Yes, it's good for the time. I would like to finish this talk with a few optimistic slides. It's about a French company that employs about 50 workers. It's not a big company, it's a small one, in end-of-life vehicle deconstruction. There is a very efficient use of technology in this facility. The activity is complex because workers have to recover a lot from car. When I say a lot, I mean reusable elements or recycled materials. At least 95% of the weight of the car must be reused or recycled. There are many different models. Some cars have been involved in an accident and they arrive in a strange state. There is no special training for that job. All the workers are mechanics. And these workers have to take a lot of initiative. They benefit, you can see it on the slide, from an IT application that provides them with the technical characteristics of the car they are going to process. With that, they can organize their work as well as possible, the way they think they will be the more efficient. And the story tells that they find it very, very useful. Last slide. Always the same facility, the same factory. As I have told before, the operator and his know-how are indispensable. And what I find very interesting on the picture you can see there is that technical solutions have been put in place to avoid physical constraints at the workstation, to avoid lumbago, low back pains, and musculoskeletal disorders. The cars are manipulated by a robotic arm. The workers doesn't have to take awkward, difficult postures. He always work standing in front of the car. Similarly, you can see it also on the picture. Most tools are assisted to prevent the worker it's the end. and it's difficult, from exerting to higher force. For example, the shears or the pliers are suspended and the force exerted by the worker is multiplied. Well, as a conclusion, I would say that all these words were simply to tell you that the issue of working conditions should not be neglected when considering the circular economy. Thank you for your attention.
Thank you, Michel. Before coming to the last speaker, I would like to remind you that after Clark, we shall have a general discussion. So if you want to ask questions, don't hesitate to use the chat. Now, Clark, the floor is yours. Right.
Hello, everyone. It's good to see you, and great to be here on such a really interesting panel to talk about circular systems. I want now to pick up where Michel left off in talking about the place that people play in circular systems, and to suggest that there could be considerable value, especially for people who are interested in health and occupational safety in the future of the circular economy, in being more ambitious about rethinking circular systems in human terms. And so to start with, let me just introduce this idea of sociotechnical systems, which is the idea that in various of these areas, whether it's communication, energy, transport, manufacturing, whatever, that we traditionally think about these systems in largely technological terms, but there are, of course, people embedded in these systems in lots of different ways. And many aspects of these systems are in fact designed specifically to address the needs of peoples in ways that reflect their values, for example, as encompassed in regulations on these systems. Of course, there are users of these systems who are critical to the design of these systems. And so when we think about the systems themselves, we should always think about them. And I loved what Michel said, his phrase that we should design the workspaces for the people, right? We design these systems for people. And at the same time, the very existence of these systems shapes our own imagination and our own daily practices of life. And of course, things that go up in scale from there to how we relate with other people, our institutions, etc. All of those are, of course, informed by the technological systems that we have built and that we operate to support modern life. So just to take a very simple example from one of your national research leaders, Mr. Bruno Latour, talks about something called a people car. The idea that the car, if someone doesn't put petrol in it, if someone doesn't get in it and drive it around, if someone doesn't maintain it, it doesn't go anywhere. And vice versa. If you think about your own encounter with a city, and you think about how you walk around the city, and how far you can imagine traveling as a pedestrian walking through the city, you are not able. You have one view of the city, but if you step into a car and start to think about now where you can go in the city, how far you can travel, your imagination of the city changes quite dramatically when you are coupled as a hybrid, he would call it, to this vehicle. So this idea of a sociotechnical system. It's this idea that our relationship as humans with our technologies has become so deep that the technologies shape who we are. And of course, we shape the technologies as well. And it's that dynamic interaction that we need to try to do a better job of capturing, I'm going to argue, in our models of circular systems. So this is a very classic example of an image of a circular economy. It is one in which we see various systems behaviors, the ideal type circularity of those systems behaviors as we take materials and we transform them into goods, and we move those goods around and we use them, and then we dispose of them, and then there are a variety of pathways by which we then take those disposed goods and try to bring them back into this new circular economy. You know, my proposition is that we pay attention in a socio-technical systems model to all of the people, and those are represented in this highly oversimplified picture by these dots. We pay attention to the people who are embedded in these circular economies in order to rethink what it's both going to take to create circular economies, and then how those circular economies will transform who we are as people, as Michel was saying in the last talk, the kinds of risks that we're exposed to, the kinds of things that we imagine as normal. I'm thinking about recycling in the United States and how long it has taken to get Americans to reimagine themselves as recyclers, as people who feed recycled products into, or feed their used products into a separate stream besides the trash can, right? So all of these things are important elements in thinking about the people in circular economies. And what I want to suggest is that when you start to think about socio-technical systems in circular economies, that two fundamental questions come to the surface. And the first is, what's the model of the human that we want to use in thinking about circular systems? And so one answer, which Michel did a great job of introducing for us in the previous talk, is workers, right? The circular economy will require an enormous amount of work by an enormous number of people. Yes, he was talking about the theoretical possibility of automation, but I will tell you there is no such thing as automation. There is only the displacement of people from one place to another. If you're going to have an automated vehicle, which we have driving around my neighborhood here in Phoenix, of course, someone has programmed that vehicle. Someone is still maintaining that vehicle. So there's no automation, there's just movement of people into different parts of the system. There's always work that people have to do, whether that's imaginative work, computational work, intellectual work, physical work, right? There's all kinds of work in a circular economy, and how that work is laid out then enables us to start thinking about a variety of questions that we might ask about work in relationship to the circular economy. So what work is required? Who does that work? What are the hierarchies of labor and management and workplace surveillance, even regimes of colonization that are embedded in that work that make it possible for the circular economy to happen? What kinds of risks, not just health risks, but financial risks, professional risks, other kinds of risks are posed by those different kinds of work? And with what degree of life satisfaction as Michel raised, do the workers have in the different parts of this circular economy, right? So this is the model of workers, right? We think about people as people are doing work of different kinds that are making the system function. But we can also think about a very different model of a circular economy and the people that are in it in terms of rational market actors, the economist's perspective, if you will, on a circular economy or a circular system. And then, of course, you know, as we think about the different elements, right, of a circular economy, we can see the different kinds of, on the one hand, firms that are present in the circular economy, firms that are doing the manufacturing, that are doing the mining, that are doing the trucking, firms that are doing the waste disposal, that are doing the repairs. But of course, they're not just firms that act in terms of this. There are also voluntary kinds of organizations like Craigslist or other sharing economy type sites. There are consumers who in this model are acting rationally on their needs and their preferences in purchasing and other kinds of behaviors that are involved in the circular economy. There is, of course, regulation. And so governments also have interests that they act on in this. And of course, one of the things that this begins to bring out is, one, that there are business models, of course. There are challenges in terms of how people are going to make money to facilitate the circular economy. But there's also competition and conflict between these different actors who may have different perspectives on how we should do distribution or how we should do recycling, or whether, particularly obvious here, whether we should prioritize reuse, redistribution, remanufacturing, or recycling as our waste disposal strategy, right? And so this is a more dynamic kind of model in which we're beginning to see the possibility that different companies might have different interests in having the circular economy function in different kinds of ways. They may have different needs, for example, in terms of business models that lead to the kinds of practices that Michel was warning us against that create health risks in the economy. So this is a different way of modeling people. It raises different questions. Whose interests is the circular economy serving? Is it monopolistic or competitive? How does information flow? Is that information transparent to all of the actors? What returns on investment is each actor expecting, et cetera, right? Lots of different possibilities for thinking about this model of what it means to be human in a circular economy. We can also think about inhabitants of a circular economy, people who are living amidst these systems, right? And whose daily lives and their practices, their relationships, their values are being shaped by this system, and their encounters with this system and the things that they like or don't like about this system. We may find, for example, that indigenous communities are not happy with the way that raw materials are sourced in a circular economy and would prefer to have more sovereignty over their lands and the resources that are embedded in those lands. We may find that marginalized workers are unhappy with the economic arrangements that are built around the business models that make the circular economy flow. We may find that people with nationalistic economic attitudes, America firsters in our recent example here in the United States, are unhappy with the ways that goods and services flow across national boundaries in a circular economy, right? And so all of these different inhabitants also are going to be forming perspectives, forming attitudes about different facets of the circular economy, potentially coming into conflict with each other. This is, if you will, more of the model of the politics of a circular economy. And again, right, raises a variety of questions, this model of inhabitants. What are the outcomes that flow for people who are inhabiting different parts of a circular economy? What are the consequences of circular systems for how people imagine the world, the values that they have, etc.? Ultimately, what kinds of people are being produced by these circular systems? Who owns the different parts of the circular systems, and is that ownership distribution fair and equitable, for example, right? So we ask, again, different sets of questions, and my point in raising these models is not to suggest that any one model of the human in circular systems is better than any other model, but that as people who are thinking about health and how health might be impacted by the rise of circular economies, we should be developing a proliferation of these different models of what it means to be human in these circular economies, and paying attention and investing in research that surfaces these different models and what they imply for how we build circular economies, right? So each one tells us something different about how circular systems will behave in the real world. And we should be building those models. So the second question then goes directly to why we would care. And that is because circular economies are not, they're not singular things. There's not only one way to design a circular economy. There are many ways we are going to discover to build circular systems. I've been doing a lot of work in the solar industry. Of course, solar energy is seen as an important element in the circular economy because it shifts us away from a scarce resource, fossil fuels, to one which is constantly being replenished by the sun as it generates its nuclear reactions and throws off photons, which we can then capture, right? And it turns out there are many, many different ways we could imagine powering a significant fraction of the world's economy with solar energy. And the design of those different systems has very different outcomes for different groups of people. And so you just have to think about, for example, if we built all of our solar in cities on rooftops and parking garages and public spaces and parks, it turns out we could actually satisfy a significant fraction of the world's energy demand without having to build any large solar fields out in rural areas. And so it's a very different model than building large rural solar fields, and it has very different human outcomes. And so that question of design, I want to take seriously and suggest that you take seriously with respect to the future of the circular economies that are built. And here's just another, frequently used diagram of a circular economy. And what it highlights is this very different design opportunity that we have, right? If we're thinking about the chemical industry, for example, and we're thinking about the feedstocks that go into that chemical industry, we can think about creating a circular economy in the petrochemical feedstock space, or we can think about the biochemical opportunities that we have for using biological systems to create those same feedstocks. Those two choices have very different implications for a whole wide array of different economic outcomes, different ecological outcomes, and so forth, even if in the end we were able to achieve circularity in both of those different systems. And so my argument is then, from the standpoint of putting together a design of a circular economy, we need to think not just about circularity and our metrics of circularity. Those are critically important, but they are not subsidiary. I mean, they're not, they don't supersede other sets of criteria that we should also be using to measure circular economies and to measure the relative desirability, if you will, of different designs of circularity. And so the argument being that we should be articulating explicit human metrics by which to measure the success of circular economies. We need to get beyond life cycle analysis, if you will, get beyond technical systems optimization to the point where we are thinking about the relative designs of different circular economies in human terms, in terms of justice, for example. And then thinking about how do we integrate those criteria into our practices with regard to the circular economy. So with that, merci. It has been a pleasure, and I look forward to the conversation.
Thank you very much. A very interesting talk. Now it's time for discussion. I would like first to thank the four speakers. It was, I think, a really interesting panel session. And now a few questions. We have one question from the attendance. Perhaps we should have addressed this question at the beginning. The question said, just circular economy will be never fully closed. There will be waste in any case. It's perhaps one of the figure to measure the efficiency of circular economy, but okay, how waste should be dealt in circular economy? I think perhaps Charles could say a few words about that because he worked on this topic also. If he's still here, well.
Sure. I'm still here. Thank you for the question. If I understand it well, circular economy will never fully close. How should the waste be
Yes.
handled? Is that the remaining waste? Well, of course, the goal is to go for an absolute minimum of waste that every part of it is of the circular economy can be reused, but of course there will be some remainings left, and yeah, it depends on what kind of waste it is. But in some cases, if nothing useful can be built out of that waste, final option could be incinerating. But the goal is to go for as low amounts of waste as possible. That is the aim, and yeah, and if some remainings are there, then yeah, case by case, it should be seen what can be done with it.
Louis, on vous...
Yes, with a microphone. I have another question. I'm afraid this is again for Charles, but if someone else wants to replay, if I understand, are bio-based chemicals identified in the list of very preoccupying chemical substance classification?
Yeah, that's an interesting question, and I visited a congress about 5 or 10 years ago in which dealt with bio-based chemistry, and then some person from a certain industry was very proud that he was able to produce 1,4-butadiene from biological feedstock. And at the end of his talk, I said, well, many congratulations with your achievement that you are able to produce it from from a non-fossil-based feedstock, but unfortunately the chemical stays as carcinogenic as its fossil-based brother. So let's focus on a bio-based chemistry, producing chemicals that are both with the lowest carbon footprint as possible, and from recyclable feedstock, but also with a lower hazard profile. So yes, bio-based chemicals are chemicals just like petro-based chemicals, and they are also classified in the current legislation system. But my point is, be aware that everything that comes from nature can be dangerous as well. So we have to keep our mind always thinking and take the right decisions on these aspects. Louis, I cannot hear you.
Organic carcinogen products, yes. I have another question, perhaps rather for Michel and perhaps Clark. But Michel, you said you presented robotics as the solution, perhaps, to reduce the occupational exposure of workers. Do you really think it's compatible with circular economy, where you deal with not very well specified equipments, high variability? Do you think it's reasonable to say that robots can do that? Nasty question.
I'm going to be provocative for once. I can't imagine the circular economy is not technological. More technological than the linear economy. Not just because I can't imagine a return to the past, but especially not because I don't believe that the circular economy is possible without majorly improved technology compared to the one we have today. We need more automation, we need intelligent robots, we need new and better performing materials, materials that can be recycled easily, for example. Maybe I'm dreaming, but anyway, there's no question for me that the happiness of environmentalists should come at the expense of workers. It must be clear.
I like that answer. I think we always need to be careful to understand where workers are being displaced, not in the sense of replaced, but in the sense of moved to a different part of the chain or the system. Sometimes that's a good thing. Other times, it relates to the question of, can it always be closed? Well, or can it be fully closed? Not only probably not, but there will constantly be new opportunities for slippage, leakage, things that escape our notice because we're not perfect at anticipating how not only the material systems will work, but the human systems around them will work. I think we will discover that there are the kinds of jobs that robots are really good at, and there are other kinds of jobs that emerge that people are really good at, and that it's cheaper to pay the people. And it's cheaper to ship the goods to Asia and let the workers there sort through them than it is to recycle it here, right? So, I think we have to be very careful in imagining that people are going to disappear from these circular systems, and that workers are going to disappear from these circular systems. But even if they do, there's also always the people who are living in and around these systems. You know, we're not going to displace people from living near manufacturing facilities or living near roads that have trucks that are driving massive quantities of sand down them at every hour of the day because there's a need to for sand and hydraulic fracturing to drill natural gas, right? So even if all of that was automated, people are still living next to those roads.
Two attendants, very good to raise questions, so I have two new questions. I prefer to read it. It's will the circular economy necessitate new safety compromises? In other words, is circular economy feasible under current regulatory pressure and precaution principle? Conclusion of the question, and perhaps the answer, ensuring safety can have a high energy cost. I'm sure everybody can say something about that. It is a little bit the aim of this session to discuss a compromise between sustainability and safety. Everyone gave an answer in his domain. I don't know if you have a question to
let me start, right? Because, you know, I think we will make trade-offs like that, but they may not always be the ones that we anticipate, right? They may not be the simple and straightforward ones. So we may choose the energy-intensive version, which then displaces into the energy system the need for more energy. My colleagues recently did a calculation of the scale of solar infrastructure that would be required to provide half the world's energy supply. It turns out in that model, you need about a 1 terawatt per year construction exercise, right? So we build this system, and even at steady state, the solar panels wear out after 25, 30, 40 years. And so there's a constant churn where we're having to take down old solar panels, recycle them, and put up new solar panels. At a terawatt a year, that's a massive construction industry. That construction industry is going to have safety issues associated with it, right? So yeah, I think these trade-offs are always going to be around, and we're always going to be making
them. Just a few words. We all know that everywhere in the world, work regulations are under attack. We all know that. And we can imagine that circular economy is used for downgrading working conditions. That's possible. Of course, I don't hope it happens, but everything is possible, and it might be a tool for people for downgrading working conditions. Yes.
Your microphone, Louis.
Okay. I have an answer also related to the first question about the compromise you have to do. If you have a pollutant in plastic, banned molecules, this you cannot recycle because you take a risk. So some plastic has to be incinerated because it's too dangerous. In fact, you have also a compromise between the risk and the level of circularity of the economy. If you want to take no risk, you burn all the possibly a little bit dangerous substance, but you can also increase the level of circularity and recycle more material. You have also a trade-off between the level of circularity and safety. Okay, if no one will answer, I have another question now. Yes, it's bioeconomy against circular economy. Let's say that the same material, plastic, could be made from biosource on being biodegradable or from fossil fuel on being recyclable. What could be the criteria to choose one of the other?
Let's go for the combination that it both biodegradable and sustainable. It's rather difficult to choose, I think, but. Louis, your microphone.
I should leave it turned on. The general question, a little bit contain all your talks, in fact. You can imagine a future when you can have several qualities of materials with no pollutant at all, or a little pollutant, or a little bit dirty, like your rubber granulate. And also you can have dirty jobs, informal jobs, engineer. So do you think that circular economy could increase the level of inequalities among consumers and workers? It's similar to what is existing in the present model. So it's a very general question. I'm sure everybody has an answer, perhaps not the same.
Well, maybe I'll start and others can jump in. I think that it could, in theory, and I would be sad, I think is the right word, if it did, because I think all of these sustainability transitions are opportunities not just to protect the environment, but to create systems that better support human well-being and human thriving. And I think we now understand quite thoroughly through a wide range of different kinds of research that if we do a poor job of designing technology, then it does increase inequality of one form or another. And so I hope that as we move towards new systems, whether that's clean energy systems or circular chemical systems or whatever, that we explicitly integrate considerations of equality and inclusion into the design of those sociotechnical systems. The difficulty, of course, is that aside from the engineering imagination, right, the imagination of the engineers of what a circular system looks like, we're rarely engaged in the design of an entire circular system. Instead, we have a company that's doing one piece, or we have a regulator that's tackling one other piece, and that partiality of how we move towards circularity leads to partial decision making that doesn't always take into account the kind of knock-on effects that occur in other parts of the system that are outside of the scope of the particular decision maker. And that's where inequality tends to creep in.
Okay. Okay, very good. Everybody is fine. Ah, I see another question. I have just to read it first. Ah, it's not very far from another one. Okay, I read this one. theoretically, there is a strong territorial dimension linked to circular economy. I think it means there is a strong local scale component. Will this actually materialize in the real circular economy? And if so, how will it challenge safety monitoring versus conventional value chains? I understand you want to address the question to have a local organization on the question to organize safety because it's generally organized at a larger level. I'm sure Michel has some things to say because he has been working a little bit on this question, on the foresight point of view, of course.
Yes, we have some examples in France of regional, territorial dimension of circular economy. Maybe, for example, in Strasbourg, where there are about 200 different firms who tell that they have a local ecosystem of circular economy. But when you look that precisely, you can see that it's very rough, very poor. In fact, they share some training sessions. They share the work of firms specialized in cleaning, but I don't think that at the moment it might come. The territorial dimension of circular economy is very strong, but we can hope that many industries are working on that subject, which say that the waste of the first will become the product used by the second, but we are very far from that. And about safety monitoring, I don't know. I can't answer this part of the question because I have no examples. I haven't seen anything like that, but it might come, of course.
Follow up with a question for Michel. Do you have a sense for how I could imagine that, you know, like our concepts of food miles or other kinds of concepts that highlight local production and consumption within a circular economy context. I could imagine that those would have real impact because of the reduced need for transportation, which means you would need fewer roads, you would need less energy, you would need fewer trucks, and that just would magnify in terms of the material consequences of going local. Is that the sense that you have?
I think the question is complex because the scale at which you recycle may depend on the equipment you want to recycle. It's a question we discussed during the foresight exercise. If you want to recycle something like a smartphone, it's difficult to believe it will be repaired, reused, recycled at the local scale, unless if it's just a small repair. So this requires a centralized organization. If you want to just to make methane for organic compounds. It's rather a local scale. So the scale depends of what you want to repair. It may be global for some smartphone. If you want to efficiently, if you want to reuse it efficiently, you need to have almost the same company. If it is just organic compound, it's local. So I think the question of the scale on the associated safety may depend on the product you want to recycle, but nobody knows exactly what will be the relevant scales for circular economy. About this question of scale, I have the opposite question on the global worldwide scale. It's a little bit inspired by discussion about Brexit recently. There is, of course, an impact of regulation on international trade. If you want to have an optimum trade, you need to have at least compatible regulations. When I hear the three speakers, I see there are several models of regulations or point of view on circular economy. For instance, in Europe, we stress the point of regulation on chemicals. It's a very important topic in Europe. Michel pointed out, underlined the question of information. If you want to repair, reuse, when you buy the product, in principle, you should have the information of the product to dismantle it later. It was the case for cars. You may need to have the guarantee to have spare parts for the repair. There may be strong regulation depending on the country. In Europe, perhaps later, we shall have regulation imposing that all equipment must be easy to repair, to be sold in Europe, for instance. So if there are discrepancies between regulation, United States, Asia, Europe, UK now, do you think that this circular economy may affect the global trade? So it's a bit the opposite question, safety on global trade. There are already many questions on pesticides, food additive, it's not a new question, but for circular economy, this may be emphasized.
We've certainly seen it impact international trade already in the solar industry. I'm familiar with a company that had established internal policies with respect to recycling of solar panels, and so they had a plan and infrastructure in place to recycle every panel that they built. And so they build them, they sell them, but then when those are to be disposed, the idea was they would go and get them and recycle them. And they were going to control the whole process, but European regulation came in and required a different approach. And so the company had to move away from that approach. And the consequence was that now they no longer have a plan at all for recycling panels outside of Europe because it's not required. So yeah, we certainly see those kinds of things happening already. And I can't imagine that they don't continue. I think regulations on lithium-ion battery recycling will have huge implications for trade in the electric vehicle space. Yeah.
Okay. Another question for the attendants. Okay, you have already two very good attendants to raise questions. It's about technology perception. Circular economy concept perceived as low-tech or technology sober solutions. And this will be really the case. So it's a circular economy with low-tech solution or high technology. In addition, this question relates to the growing public aversion to technology, at least in some part of Europe. So we have the image of the fully robotized economy and the image of rather close to bioeconomy and low-tech economy. How do you perceive circular economy?
I've already answered that question. I think that a circular economy with low tech can't work. Maybe for food or some things like that, but I'm pretty sure that we need a very advanced technology to make a well-working circular economy. But the possibility is that circular economy will never work.
Okay.
Oh, I'm sorry. The word was not low tech; it was
Yes.
sober
Yes.
technology. My answer might be a little bit different. I don't know.
There is also a related parameter we discussed for the foresight. You can imagine to a circular economy one with the consumer buying as many goods and equipment as now, or a more sober economy with a lower level of life. So I would say circular economy circulating more slowly. You can imagine different type of circular economy. Presently, if you discuss market economical actor, of course, you are rather on the side of to try to live as now, but with technological solution to improve recycling. But there are because the question is.
I can give.
Yes.
Sorry, I can give an example. For example, if you want to grow organic food, organic plants without pesticides, the best solution, I think so, the best solution is to use a robot. There are some robots now who allow the farmers not to use pesticides. It's not a sober technology. It's not a low-tech technology.
Yes, very good example. Yes.
May I comment on that from an environmental perspective? Well, the solution to use robots rather than workers for let's call it dirty jobs. Of course, the spin-off may be that more of those pesticides or hazardous chemicals are being used in factories or in recycling factories with a spin-off to the environment, because in the factory itself, there is no problem, but there may be discharges or whatever to the environment, and so it should be in balance. So we should focus both on workers integrated to the environment. So that's the point of putting forward robots as the solution to use dirty chemicals in our society for a much longer time. So there's a little bit green noise from the Netherlands, but let's keep that in mind. That we should see it in an integrated way.
Okay. Alors, okay, I just look. Already another question. Okay. I was expecting it's rather a comment or a question. Yes, related almost to the slide of Walter. In fact, couldn't we consider that the 19th century economy was the largest circular one? This is a
Go further back than that, but not too much further.
Yes, yes, because before the Industrial Revolution, if possible, to keep the coal consumption low.
Right.
Yes. But this shows that there are several views of what could be an ideal world with circular economy. There is no unique view. Clearly, some of us rely on technological solutions, provided they are cleaner than present solution. Some of one see rather to go back to the past solutions. So I think it's a political question. Everybody has a different view, and there is no solution to this question. Everybody has a solution, but there is no common solution.
Well, I prefer to think of it the other way, right? I prefer to think of it as a design question. There's not one model. We have to be deliberate about the design choices, and the design choices are not circular versus not circular. They're partially circular A versus partially circular B versus partially circular C. And so we need robust criteria. That goes back to that earlier question, which I liked, which is what criteria should we use to choose among our circular models? And I think that it's a very tough question. So in the solar industry, for example, we have an interesting challenge. For the business model of solar energy, you want the lowest levelized cost of electricity from the solar panel. One of the biggest impact factors on that is the lifetime of the panel. The longer the panel lives, and the more reusable the panel is beyond its initial lifetime, the more energy you're going to get out of that panel. And so the lowest material and financial cost per unit energy produced. But if you're going to try to get something to live 50 years out in the sunlight and the rain, it has to be unbelievably durable. And if it's unbelievably durable, then it takes a lot more effort and a lot more energy and a lot more chemicals to recycle it. And we already see that trade-off being made in the solar industry, and different people making different choices about which aspects of circularity to emphasize in that regard.
About the comparison of the 19th century and the beginning of the Industrial Revolution, I would say at this time there was much less people on Earth than now. To have an economy running with the billions of inhabitants we have on Earth is not exactly the same question that more than 1 century ago. You can imagine a small ecological footprint 2 centuries ago, but if we would like to do the same thing today with the same number of inhabitants, I think the answer would be different. Okay, I see no other question, but I can ask one related to the talk of Charles and Michel, at least, because both of you stress the question of information, to have the traceability of the content of chemicals in materials, to be able to follow them. Michel, the information on equipment, possibly 20 years later, or even of components. Not only the information, but also the information on the reliability of components. So, do you think this is manageable? It's a wish, but
yes. Well, to be honest, because I mentioned the wording of a material passport, and in the Netherlands also people are in favor of a track and trace system. And well, I'm familiar already a long time with the REACH system, in which industry has to make entries of their use and what categories, etc., etc. And to be honest, it's still rather incomplete. So we already try to build a system where at least the producers, the chemical industry, could put their data in, hopefully making transparent where a chemical goes when it leaves the manufacturing industry. But its downstream uses are so difficult to follow. So yeah, that's not the ideal example, I think. And of course, for example, also the European Commission is also going for a data-based it's called the SKIP database, in which chemicals of concern in consumer products should be the data should become present, and industry are obliged to fill that database, and hopefully with that information you have a kind of track and trace system where a chemical ends up in a first life cycle stage product. But whether it's manageable, to be honest, I've got my personal doubts, and I think it's better to go for a long-term solution that we try to avoid the use of hazardous chemicals as much as possible, for example, by discriminating between essential use, non-essential. But there is more going for bio-based chemicals, which are not only sustainable, but also with a low hazard profile. So in the end, we should go for the solution that it's impossible to say that we go to a society where there are no chemicals that are not dangerous anymore, because we need some functional aspects of chemicals. But incorporating data in a database is challenging, and but there is a long way ahead to make it successful, I'm afraid.
I see. A question about what about using DNA marking? It would be a way to mark raw materials. The key issue would be to have a common. Well, yes, there are in fact two sub-questions. Yes, what about DNA marking as a way to have an identity code of materials, but also the key issue is to have a common system spread globally, because the question also is to have a local traceability at the scale of Europe and worldwide. This is not exactly the same question. So.
I can say that as I'm working in strategic foresight, I have no opinion, but it would be a little bit too easy. I will say that I think that circular economy and linear economy will coexist in the decades to come, and it's very, very difficult to imagine now how far the circular economy will go. But I don't think it's able to make all things that linear economy does. That's a proof answer.
Yes, I can add, but beyond the possibility to keep information and about everything everywhere, there are many research also on online analysis of chemicals. You can analyze online a plastic piece to see what is inside. If you have not the information, you can try to retrieve it before sorting this material. And there are also about dismantling equipments, people thinking on software to help people, as Michel shown, but also taking into account possible failure inside the equipment, which can generate a risk. Because Michel showed you a system where you have just the information on the car, for instance, but you could have also, in addition, a computation telling you, be careful, in 1% of case, there is still a battery, a charged battery, this part can be broken and it's dangerous to remove it. You can have also an expert system telling you what are the uncertainties when you want to dismantle it. There are some reflection. So it's a way to retrieve information and also to add information on the possible failure when you want to dismantle the equipment. So you try to retrieve it.
I would say that at the,
yes.
I would say that at the moment workers are much cheaper.
Yes. Okay. It's 6 o'clock and I see no more questions. In a case, we had a lot of questions. Okay, with 2 or 3 very good attendants to find questions and other ones also. So it's very sad we cannot applaud in such an organization. But I would like to thank, I'm sure all the attendants agree with me, to thank our 4 speakers for such a discussion, sometimes about difficult questions without any clear answer. Okay, someone wants to add something? Okay. Goodbye and thank you. We discuss that again in 50 years. Okay.
Okay.
Right.